Welcome back. Let's solve this integral. Now over here you can see in denominator as well as numerator you have even powers of x. Here also you have even powers of x. So in these type of questions, what we used to do is we used to divide numerator as well as denominator by x square. Okay. So let's divide numerator as well as denominator by x square and let's see what it comes. So is equals to integral. So I am dividing denominator as well as denominator by x square. So 1 minus 1 by x square upon here it become x square plus 3 plus 1 by x square into tan inverse x plus 1 by x into dx. Now what about this? Okay, look at here, this. Okay, this is what is equals to integral 1 minus 1 by x square dx. This I can write like this, a plus b whole square. Let's see if I want to express this of the form x plus 1 by x the whole square. If I expand, this is x square plus twice ab plus b square. Okay, now x gets cancelled. What we have 2. Okay, x square plus 1 by x square is we have 2. Okay, so 2 plus 1 into tan inverse x plus 1 by x. Now here if I substitute this x plus 1 by x as a u, then I will be getting du as this. Okay, now let's substitute u equals to x plus 1 by x, then my du equals to 1 minus 1 by x square into dx. So whole this become what? My du. Okay, therefore this integral is du upon, this is what? U square. Okay, so u square plus 1 into, this is tan inverse of u. Okay, remember d by dx of tan inverse is what? 1 upon 1 plus u square plus 1. So I can write this is same as 1 upon u square plus 1 upon tan inverse u into d. Okay, now if you differentiate this, if you are getting this, then that is log, means integral of 1 by x or dx is log of x plus some constant. So this is equals to what? This integral equals to log of tan inverse u plus c. Differentiation of tan inverse u is 1 upon u square plus 1. Okay, so this is, now what is u? Log of tan inverse, what is u? U is here x plus 1 by x plus c. Okay, this is the required answer.